Alright, so the last part of your packet should be 4 questions that are missing the dividend, divisor, and the quotient. I'm going to be giving you the dividend and the divisor, and you're going to have to try and figure out what the quotient is using the area model. Now, it's not uncommon for students to be very lost the very first time that they've seen the area model for division. I will tell you it's definitely not as easy as the area model for multiplication, but just like anything, you need to practice it to get better at it. So to say that you hate it or just like you just want to give up, that's obviously not the mentality that I want you to have. So let's do some together, and then there will be periods where I might ask you to pause the video, and that way you can take some time to try things on your own, and then you can check it after you play the video. I will go through the question. So let's look at the first one. For the first one, I want you to fill in the dividend as 57, and your divisor, I want that to be 3. And so the quotient will still be missing. We'll try and figure out the quotient together. So 57 divided by 3, I'm going to create my rectangle, and so should you. I'm literally doing this with you. 57, remember, is the area. The dividend is the same as the product, so from multiplication. So 57 is the area of this entire rectangle. And so 3 is the divisor, which is one of our factors from the multiplication problem. So I now know that 3 times something up here gives me 57. I don't know what that something is, so I can use division to help me figure that out, because think of it almost like a variable. 3 times a equals 57. In order to solve for a, I have to rearrange it. 57 divided by 3 will give me a. So I now am going to ask myself, and this is the most important question of division, how many groups of 3 can I pull out of 57? And so if I have 57 Skittles and I want to see how many groups of 3 I can make, I'm going to think about some of my facts that I already know. Being that this is a double-digit quotient, I'm going to think of a double-digit partial quotient that I could use. So I know, like, I could pull out 10 groups of 3. That would be 30. I could not pull out 20 groups of 3 because that would be 60, and I don't have enough Skittles to do that. So I'm just going to stick with the simple stuff of like 10, 20, 30, 40. It should be a multiple of 10. Those are much, much easier than trying to do like 11 or 12 or 13. Stick with simple, quick tricks, double digit. So I could pull out 10 groups of 3. Now if I pull out 10 groups of 3, that's only going to be 10 columns and 3 rows, which is a total of 30 X's. So I know that I didn't take care of all of that. And so if I do 57 minus 30, I'm going to be left with 27. And I know that there's still going to be 27 X's on here. So I'm going to split this right now. I'm going to pretend like this is a 3 by 10. And that means that there's 27 X's still left over. So I'm basically transferring that over into this other rectangle. And so I know the area of this rectangle is 27. And I have the length, which is 3, but I don't know the width. So in this case, I can do 27 divided by 3 to figure out what this is. Or I can ask myself, how many groups of 3 can I pull out of 27? In this case, 9, because I know that 9 times 3 gives me 27. That's going to take care of all 27 Skittles, for example. And that means I have none left. And at this stage, when I have none left, I know that my partial quotients are done, and all I have to do is add them together. So I'm going to do 10 plus the 9. And what is typically a factor right here for multiplication is now going to become my quotient. So in this case, this is 19. And just so that you know, if I was doing this like with multiplication of like 3 times 19, it should look very similar to the area model that we have above. You don't have to copy this down, but you'd have 3, then you'd have 10 plus 9. Notice that's just like above. You'd be splitting it here. You'd have 30 X's here, 27 X's here. That's a total of 57 X's on the inside, which is why we had 57 to start with. All we're doing is we're repeatedly subtracting out groups of 3, which is why it's division.